All right, so this is Math 146, Unit 6.2, ellipses. The easiest way to kind of think about an ellipse is most people think of this as being a stretched circle. In reality, really a circle is a special kind of ellipse where there is no stretch, but that's the way most people are going to think about it. So an ellipse can look something like this, where it's kind of stretched out along the x-axis, or an ellipse can look something like this, and these are just general forms where it's stretched more along the y-axis. Ellipses can obviously be rotated. They can be stretched over a whole bunch of different axes and shifted off of the origin being the center, and we'll deal with a little bit of that. But that's basically what you want to think of as the way an ellipse looks. And then again, a circle is a special form of an ellipse where there's no stretch whatsoever and everything is exactly the same distance from the center. So the actual definition mathematically of an ellipse is based upon foci. So an ellipse has multiple foci, which is the plural of focus. So in 6.1, we talked about the parabola. A parabola has a focus, and it's one singular focus. An ellipse actually has multiple focus or foci, and the definition is this. Every single point that you have along the ellipse is going to be the same distance as the sum of the distances from the foci. What do I mean by that? So let's take some random point up here on the ellipse. If I were to take the distance from the left foci to that point, and then the distance from the right focus, to that point, and I were to add the two blue lines that are created there, whatever that sum is for those two blue lines distances, it will be the same at any point around the ellipse. So in other words, if I put a point over here, and then I were to take the distance from the left focus and the distance from the right focus and add those two orange lines, it would be exactly the same as the sum of the two blue lines. So that's ultimately what the definition of an ellipse is mathematically. So it will be the sum of the distances from the two foci to any point, and that will be the same all the way around the ellipse. And if the ellipse is in the form of the one that we have the sketch going, where it looks like it's more stretched in the x direction, the foci are actually going to be 2 points. The first focus is going to be at the point -c, 0, and the second focus will be, as you might predict, +c, 0. So they are exactly the same distance away from the center, and the center of this thing in this case is at the origin, and they are along what is considered to be the major axis, and the major axis is the one with the longer stretch. So the major axis in this case is the horizontal axis. And that's the one that's along the x-axis. And then, as you might expect, you have a minor axis, which is the one with the smaller stretch. And in that case, this is the vertical. And that would exactly switch for the one on the right-hand side. The major axis would be your vertical, and the minor axis would be the horizontal, and that's the graph on the right-hand side over there. And the one on the right-hand side, the foci, would then be along the y-axis at some points. So your first focus would be the point 0, -c, and then your second focus would be the point 0, +c. And the nice thing about the ellipse is you don't have to worry too much about positive and negative signs when it comes to the standard equations of an ellipse, because in this case, everything is going to be added together. So, and all this stems, again, from a distance formula, but I'm just going to give you what the formulas are here for the ellipse. So what you have is you have x squared over a squared plus y squared over b squared equals 1. That's going to be the general equation of an ellipse as long as the x-axis is the major axis. If the y-axis is the major axis, the only thing that's going to change is the location of the a squared and the b squared. Those are just going to change. So if it's under the y-axis, the x squared would get the b squared in the denominator, where the y squared would give you the a squared in the denominator. And the reason for that is because the a value is actually going to be the location of the major axis vertices. So the a value here would be at a comma 0. And then, like you might expect, over here would be negative a comma 0. But you still have vertices along the minor axis, which is going to be up here, and that's where the b part comes in. So this would be, because it's on the y, it's going to be 0, negative b, and then up here it will be 0, positive b. And again, the only thing that changes when you go to the graph on the right is that the a and b switch. So in this case, your major axis is this one. So that's where your a value is going to be. So it'll be 0, comma a, and then 0, comma negative a. And then the minor axis have the b's. I'm not actually going to write those in there just to save a little time. All right. So this is the common equation. And the nice thing is, in order to find the b value, or the a value, I guess technically, actually, that's not really what we use this formula for. This formula is pretty much primarily going to be used to find the foci, but you can use it to find any of the missing pieces depending on what you're given. So there's an equation, and it looks very similar to a Pythagorean theorem, and technically it is a Pythagorean theorem, just that your a, b's, and c's are slightly mixed up. You're going to use this equation, b squared equals a squared minus c squared. Okay, and that's going to allow you to find either a or b or c, depending on what you need to find, given certain things. If you're given the focus, then you're going to have the c values. If you're given the major axis, you're going to have the a values. If you're given the minor axis, you'll have the b values, and so on. And what you can see is that technically, if you were to add c squared to both sides, you really have a Pythagorean theorem. The only difference is that a squared in this case would be the hypotenuse, as opposed to the c squared, which is normally your hypotenuse, or the a and the c, excuse me, and not the squaring of them, but hopefully you understand what I mean by that. All right, so this is actually the equation of an ellipse. Now, let's think about this real quick because we're not going to really go into it a lot. If a and b are the same value, which means that the distance from the origin or from the center of the ellipse out to the major axis and the distance from the origin or the center of the ellipse to the minor axis happen to be exactly the same, then you have a circle. And that should make sense because you would really get something like, I don't know, 5x squared plus 5y squared equals 1. That would just be the equation of a circle. Something like that. All right. Let's see if we can actually find an equation of an ellipse given some specific information. So let's do a couple of examples. So in the first example, we're going to write the equation of the ellipse centered at the origin. It's telling us that one focus is at the point 3, 0. And it's going to tell us that a vertex is at the point -4, 0. And when they say vertex, they mean along the major axis. Otherwise, it would be considered a minor vertex, I guess, or covertex. I actually can't even remember the name for that. It might be a covertice if it's on the minor axis. I have to try and remember that terminology. So this is the information given. Let's use this to now try and write the equation. All right, so let's look at our equation here and see what we're going to need. First of all, the focus is 3, 0, and the vertex is -4, 0, which tells me that this thing is lying on the x-axis because it did say it was centered at the origin. So that means that we're going to use the equation x squared over a squared plus y squared over b squared is going to equal 1. They have given us, because they gave us the focus, they gave us the c value, so we know c is 3. They have given us the major vertex, so we know that a in this case, it says -4, but that's just because of direction. So we know that the a value is actually 4. So we're going to go ahead and use that to find b, because really what I need to write the equation is I need a and b. Well, I have a, we just need b. So let's go to our equation here that says b squared is a squared minus c squared. So b squared is going to be a squared, which is 16, minus c squared, which is 9. So b squared is 7. And technically we could solve for b, especially if we were going to be graphing this, which, you know, we could always sketch a graph of. Not necessary in this case, but we don't need to solve for b because we really need b squared. That's part of the equation. So we're going to have x squared over a squared, which is going to be 16, plus y squared over b squared, but b squared is 7, equals 1. And again, that is a perfectly legitimate equation. This is, I personally call this the intercept form of an ellipse. There are other ways that you can see ellipses written, and just to give you an idea, you could take and multiply by the common denominator of whatever the common denominator between 16 and 7 is, and multiply that on both sides, and that would also be the equation of ellipse. It would just be the equation of ellipse, not in its standard form where you have 1 on the right-hand side. But we'll get to something like that when we get a little bit further. So there it is. There is the equation of our ellipse. And we're not going to worry about sketching this one right now. We'll do that with a later problem. Probably the next one, actually. All right, so let's take a look at another example. And in this example, we're actually going to be given the equation of the ellipse. So x squared over 25 plus y squared over 9 equals 1. And in this case, we want to come up with the location of the vertices. We want to come up with the location of the foci. And we're actually going to go ahead and sketch this one just to make sure we can see what it looks like. So really, this is not very difficult to do if it's in its standard form, just like you see it here. I know this is centered at the origin because there is nothing being added or subtracted to the x or y. There's no h or k values. This is the same general principle that we use for parabolas. When we end up shifting these things off of the origin, we're going to have h and k values. There aren't any of those associated with x and y, so we don't have to worry about that. What we are going to look at is how do I find the major and minor vertices? Well, those are given to us technically in the problem. And because the larger value is underneath of the x squared, we know that the x-axis is going to be the major axis. And the way you would actually figure that out, if you didn't know that, you could always just find the intercepts. If I want to find the x-intercepts, I'm going to let y equal 0. And if y equals 0, that whole term goes away. I'm going to take the x off of there just because I want to make sure we see it. But that y squared term goes away. And then basically what you would have left is x squared over 25 equals 1. Multiplying both sides by 25, and then taking the square root, you would get the x values have to be plus or minus 5. So I know that 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 in either direction is going to be my major vertices. So my vertices are going to be the points plus or minus 5 comma 0. Okay, I can find the co-vertices or the minor axis vertices. Same idea. If I want to find the y-intercepts, we're going to let x equal 0. So if I let x equal 0, I'll put this right here. That means I have y squared over 9 equals 1. Multiplying by 9 gives me y squared equals 9, so y would be plus or minus 3. So 1, 2, 3, 1, 2, 3. And you can certainly see how the stretch is going to be much bigger in the x direction than in the y direction. And then we can go ahead and sketch right through those vertices and co-vertices. And that's just a sketch. The only thing we haven't found so far is the foci. It comes from the exact same equation that we used before, which is going to be that b squared equals c squared minus a squared. And that comes from, right, a squared minus c squared. Wow, I just totally said it backwards. I apologize. B squared equals a squared minus c squared. So it's the same exact equation to find the vertices. Now, one thing I can tell you, and you would hopefully figure this out pretty quickly, if I had done it backwards like I accidentally just said, you would have ended up with having a negative value to try and take the square root of, and that should be a red flag. Oh, I did something wrong. So hopefully that won't happen, but if it does, that's a good way to check. So in this case, b was 3, or b squared is 9. A squared is 25 minus c squared. So now let's go ahead and solve for c. If we subtract 25 on both sides, we get negative 16 equals negative c squared. Dividing both sides by a negative value gives me 16 equals c squared, or c is going to be plus or minus 4. And so that gives me 1, 2, 3, 4. There's one foci. 1, 2, 3, 4. There's another foci in the negative direction. My foci in this case are going to be plus or minus negative 4, comma 0. And again, I didn't write the actual co-vertices out, but you can see where those would be. Those would be at 0 and then plus or minus 3. All right. I think that in general, ellipses are going to be slightly easier to deal with. At least I hope so. So let's try one now that maybe is stretched in the other direction. So let's go with another example. And in this case, we're going to take a look at, and this is going to be one, like I said, that's not already in that standard form. So we're going to get it there. It's 9x squared plus y squared equals 9. And so how do I get this into the standard form? Well, the general idea is, first of all, you should be able to see that everything is being added, x squared and y squared, they're both positive. Okay, that's important because eventually if one of those becomes negative, then it's a different conic section, which we'll get to in the next section. But for right now, we need to get that right side to equal 1. Well, the best thing to do is simply to divide everything by the number on the right side. So if we divide everything, it's supposed to be in green, by 9, we'll then put this into standard form. So 9x squared divided by 9 is going to give me x squared. Technically, that's over 1, if you want to leave it like that, just so you can see it. The next one is just y squared over 9. And then the right side now becomes 1. And that is now in standard form. The bigger value underneath of the x squared and y squared is the 9, which means that is your major axis. So it will be along the y-axis. and hopefully you'll be able to see this pretty quickly, but if you let x equal 0, that term goes away. You'd have to multiply by 9 on both sides, or you can look at this and just say, well, why don't I just take the square root of the a value, or the a squared value of 9, and know that it's positive and negative 3. So we're going to go 1, 2, 3, 1, 2, 3, positive and negative 3. That's going to be my major axis. And then if you look at your b squared value, which is 1, taking the square root of that will give you positive and negative 1. So it's going to look something like that. And then we will sketch our ellipse right through there. And then the only thing that we still have left to find is the foci. So let's go ahead and actually write this out. B squared equals A squared minus C squared. B squared in this case was 1. A squared was 9. So if you subtract 9, divide by a negative, then we would get C to be the plus or minus square root of 8, which you could simplify if you wanted to the plus or minus square root of 2. 2 square root of 2 to find that. So let's go ahead and actually just write out the foci and the major axis vertices. So the vertices are going to be at 0 plus or minus 3, and then the foci are going to be at 0 plus or minus 2 root 2, or you could just leave it as the square root of 8 unless it says to simplify that. And if we wanted to sketch where that would be, where the foci would be, the square root of 8 is just a little bit less than the square root of 9, so it's going to be pretty close to the ends here, someplace in between the 2 and the 3 and the 2 and the negative 3. So that's where your foci would be. All right, so now let's do one where we have shifted this thing off of, off of the center being at the origin. So again, it's the same general form that we used when we talked about parabolas. It's just going to look like this. Actually, let me give you the general form before we do the example. So something not necessarily at the origin will look like x minus h squared over, and in this case, we'll just put the a squared under here to say that that's going to be the major axis, plus y minus k squared over b squared equals 1. All the rest of the stuff is going to be very similar, excuse me, to what we did before as far as finding the foci. We just have to understand where the actual center is to know which direction to go once we get the information for the foci. So let's go ahead and take a look at an example, because I think that's the best way to do it. And we're going to combine a whole bunch of stuff in this one specific example. You know what? No, let's do 2 different examples. Let's take it a little bit slower. We got some time. Even if it takes us a little bit longer, it's fine. So the first thing, it just says, find the equation of ellipse not centered at the origin. So we're just going to write the equation of the ellipse not centered at the origin. And what we're going to be given is this. The center is going to be told to us as 2, negative 3. It's going to tell us that one focus is at the point 3, negative 3, and one vertex is at the point 5, negative 3. If nothing else, you should definitely see that there's a pattern in the fact that all of the y values are negative 3. That should tell you that this is going to be stretched along the y-axis, since the y value is not changing and all the other points are located someplace else at some x value. I'm sorry, it's going to be stretched. I don't want to say along the y-axis. It's going to be stretched actually horizontally, where the major axis is actually going to be horizontal, because it's the y value that's not changing. So that's steady. It's the x values that are changing. So if you really wanted to, you could certainly sketch this. And let's see, it's 2, negative 3, 3, negative 3, and 5, negative 3. So the center is at 1, 2, 1, 2, 3. The center is right there. And then there's a focus at 3, negative 3, which is going to be right about there. And then there's a vertex at 5, negative 3. which is going to be out here. So by symmetry, the other focus has to be, well, let's see, that would be from 2 to 3 is one space. So it's got to be one space in the other direction from the center. So the other focus has to be here. And then again, by symmetry, we're going from 2 to 5, which is 3 spaces. So it's got to be 3 spaces to the left. So 1, 2, 3, we're way back here. 1, 2, 3, I actually made that too far. It should be right about there. And now we're going to have to do some information here to figure out the minor stuff, but we can get to that. So what we've really been given is some of the A value stuff. We were given the center, which is really nice. So I know that my numerators of these things, it's going to be x minus the h value, which is the x value, over, and this part is going to be my a squared, because it's the major axis, plus, oops, don't forget my squared up there, y minus the y value, well, minus 3 is plus 3. And then that'll be over the b squared equals 1. Okay, now we need to actually go ahead and figure out the rest of this. Okay, starts the same way. B squared equals c squared minus a squared. Man, that is the second time I've done that. I don't know why that's in my brain right now. A squared minus c squared. Again, I would have figured it out, but I don't know what's going on with my head right there. All right, so let's figure out our b value. We already have our a values. We're good there. Let's figure out the b value. So b squared, a in this case is going to be 3, because that's the distance from the center out to the vertex. So from 2 to 5 is 3. So a is 3. We'll write that down actually up here just to make sure we have it. A is 3, and we'll write our c value down because we're going to need that. So that's going to be 9 here. C is the distance from the center to the focus, which in this case is 1. From 2 to 3 is 1. So that's 1. 1 squared is 1. So we get that b squared is 8. Or b is the plus or minus root 8. So the b value is actually the square root of 8, or again, you could write that as 2 square root of 2. I'm just going to leave it as the square root of 8. It's going to be easier when we simplify. So I'm not going to fully finish the sketch here. You could plot those values, but the important thing is now we can write the equation of the ellipse, which is going to be x minus 2 squared over a squared. A squared is going to be 9 plus y plus 3 squared over b squared. Well, b itself was the square root of 8, so squaring that gives you 8 equals 1. And that right there is the equation of our ellipse. Again, we could find all the other pieces. We could find the vertices, which we technically have kind of sketched there. We could find the foci, which again we have sketched there. We could find the minor or co-vertices. We don't have those sketched there, but we could just by going up and down the minor axis by a grand total of the square root of 8 away from the center. So that's how you would find that information. All right, one more, and this is going to be where we're going to combine a bunch of stuff. So the last example says we're going to be given the equation 4x squared plus y squared minus 8x plus 4y plus 4 is equal to 0. And you're probably looking at this thinking that is not in anything like the standard form, and you are correct. We are going to have to do multiple completing the squares in order to get this into its standard form. So let's go ahead and start rearranging things and rewrite it. First thing you want to do is group your x terms. So 4x squared minus 8x. I'm going to leave a little bit of space, plus y squared plus 4y, group the y terms. And I'm going to move anything that's a constant to the other side of the equal sign. Again, leave a little space. We're going to subtract 4 on both sides. Hopefully that makes sense. I just rearranged the x terms first, left a little space after that, put the y terms in there second, left a little space after that, and then I moved that positive 4 to the right by subtracting 4 on both sides. So now what we're going to do is we're going to complete the square for both x and y. And remember, to complete the square, you take the linear coefficient, divide it by 2, and then square it. So for the x part, we're going to take -8, divide it by 2, and get -4, and then square it will give us plus 16. For the y part, we're going to take the 4, divide it by 2, which is 2, and then square it, which is 4. But remember, I just now added 16 and 4 to one side of the equation. I also need to add the 16 and 4, or 20, to the other side of the equation to keep it balanced. So now we're going to take this group, that group, and factor them. And those should be perfect squares when we do. So, technically, I probably should have done some factoring work up front, but it's okay that I didn't. You should see in the first set of parentheses, I can factor the 4 out, which will leave me with x squared minus 2x plus 4. And then the second one, I'm just going to rewrite for now, and we'll factor it all at the same time. And then that's going to equal 16. Something is not right. Okay, I think I see what it is that went wrong, although I'm still actually not sure why it's not working even in the form that it's in. But so I'm going to erase a couple of things with just the x parts. You can leave the y parts alone. This part right here is going to be slightly different. So I think the part of this, and again, I'm not really sure why it doesn't work out when I do it the other way. I'm going to have to check some stuff later. We need to actually factor the 4 out first. So I'm going to factor the 4 out and still leave that space. Believe it or not, the stuff on the right is still going to be the same. But when I complete the square now, I'm only completing the square with what's inside the parentheses. So if we divide -2 by 2, we get -1, and square it, we get +1. We still should have added the 4 to the right-hand side. So actually, no, the right-hand side is completely off, I believe. Let's find out. So I'm going to go ahead and write the -4 in here. We definitely added 4 when I did this stage. But down here, keep the +4, we also now added another 4 because technically that has to get multiplied together. That's what we added together. So I believe we should have another +4 over there. So it shouldn't have been a 16 like I had in the first place. Again, I'm not sure whether this still would have worked out the other way. Just this way is actually the easier way to do it. Now, this is a perfect square. That's a perfect square. We can go ahead and factor those. So I have a 4 still out here. Got to leave it out there. This is going to become x minus 1 squared. And then this one is going to become y plus 2 squared, factoring that. And on the right-hand side, I've got -4 plus 4, which is 0, plus another 4 is 4. So now to put this in standard form, we're going to divide everything by the 4 on the right-hand side. Which is then going to give us the equation x minus 1 squared. Technically, that's over 1. Plus y plus 2 squared over 4 equals 1. And what you can see is that your major axis in this case is going to be along the vertical one with the y values, and the minor axis should be along the horizontal one with the x value, since the bigger value is underneath the y term. Your center is your HK value, which in this case should be 1, -2. Because remember, it's x minus h, so we already have the x minus in there, so the h value is 1, and then y minus k, but to get a +2, then it would have had to have been, k would have had to have been a -2. So there's your center. And again, it's going to be stretched more along the vertical axis with the y's. So your first vertex or vertices, it's the y values that will actually change in this case. So it'll still be along 1, comma something. The a value is going to be 2, so we need to add and subtract 2 from the center to get there. So adding 2 to the center would get us to 0, and subtracting 2 from the center would get us to -4. So those should be your two vertices. And then if we want to find the foci, now we actually have to find the c value. So let's do b squared equals a squared minus c squared. Got it right this time. So b squared in this case is 1. A squared is 4. Subtracting 4 on both sides. Dividing by a negative. So c is going to be positive or negative √3. So if I want to find the foci, again, those have to be added or subtracted to your center. This is not going to come out as clean. The center is 1, and then we're going to add and subtract a √3 from -2. So it'll be -2 plus √3, and then 1 comma -2 minus √3. And those are going to be your foci. Again, you could find the co-vertices, not really stressed about doing that one right now. That's the information that you'll need. Again, there's lots of practical applications for ellipses, which is really awesome. Planet orbits pretty much are in elliptical patterns. You can actually design things with ellipses. If you've ever been in one of those, what do they call them, whispering galleries or something like that, where you can literally stand at one point in a gallery, but because of the way the shape of the room is, it's elliptical, you can talk to somebody who's way far away in a whisper, and they can actually make it out clearly because of the way the sound bounces off of the elliptical shape. Pretty cool thing if you ever get a chance to do something like that. Might have one at like the Science Center or something. Anyway, that is plenty enough for the ellipses video. The last of the conic sections will be hyperbolas, very similar in formula, so we'll try to hopefully come up with a way not to get those confused. All right.